So we are asked to find the general shape and direction of this graph over the interval from negative infinity to negative 2. And this is the piecewise defined function that we were given. We would read this as r of x is equal to negative 6x minus 12 as if x is less than or equal to negative 2, or r of x is equal to 2/3 x squared if x is greater than negative 2. So this interval that they're talking about, negative infinity to negative 2, is this interval. It's everything less than and including negative 2, right? Everything less than and including negative 2. So this particular question is asking about this part of the function. Well, if you look at this is a linear function. This is the equation of a line. Remember, f of x is equal to mx plus b. This is your slope and this is your y-intercept. And since the slope is negative, it's going to be falling from left to right. So it's going to be going this way. So the general shape is a line, a straight line, and the direction is decreasing or falling from left to right. So that's how you would answer this part of the question. But let's continue this and see what it actually looks like. What if we were asked to sketch the graph of this piecewise defined function? Well, our intervals tell us what each part of that function looks like. So for x less than or equal to negative 2, I need to pick x values that fit that interval. I think maybe I'll start with a negative 4. Then I'll go to negative 3, then I'll go to negative 2. I include negative 2 because it is included in that interval, right? So I take the negative 4 and I plug it in this part of the function because that's the interval it falls in. So negative 6 times negative 4 minus 12. I really didn't want to do this in my head. So I'm going to grab my phone real quick. I didn't have my calculator nearby. So negative 4 times negative 6 is a negative 24. And then negative 24, or sorry, positive 24, I'll get it right in a minute, minus 12 is 12. Now we plug in negative 3. Negative 3 times negative 6 is 18. 18 minus 12 is 6. Sorry, my video froze. There we go. Now negative 2. So negative 6 times negative 2 is 12. 12 minus 12 is 0. So for this part of our graph, I don't know if I can squeeze it all in there, but I'm going to try. So negative 4 and 12. There we go. Negative 4, 12. Negative 3, 6. And negative 2, 0. Now remember, this keeps going in that direction because it says all the x's less than or equal to negative 2. That's all these x's going this way. So that means this part of the graph is supposed to be a straight line, by the way. Looks something like that. It keeps going this direction, but it stops here because this interval stops here. So we're finished with this part. Now let's move on to the second part of the piecewise defined function. In the second part, we are told that x is greater than negative 2. So is negative 1.9 considered to be inside this interval? Negative 1.9 is definitely greater than negative 2, even if only by a little bit. So we need to include every number close to this negative 2, but not including negative 2. So when I do something like that, I put that negative 2 in there, but I put a little circle around it so that I remember, hey, I can't include it there. Okay, so I put that negative 2, and then I need all numbers greater than that. So maybe I'll try a negative 1 and a 0. You can choose any numbers greater than negative 2 that you like. I'm just going to try those. I might actually try a different number. That's okay. We'll just leave it that way. So negative 2, if we were to put that in here, negative 2 squared is going to be a 4. And then we're going to have 2/3 times a positive 4. That's going to give me an 8/3. So that one would go there. Then we have negative 1 squared. Well, that's 1 times 2/3 is 2/3. 0 squared is 0, and 0 times 2/3 is 0. So what does this part of our graph look like? At negative 2, we're at 8/3. 8/3 is the same thing as what, 2 and 2/3? So at negative 2, we go up to 2 and 2/3, something like that. But remember, it doesn't actually exist there. So we leave an open circle on our graph. Then we have a negative 1 and a 2/3, which is really, really close. And we have a 0, 0. Now, I'm not quite sure what this graph looks like at this point. So I might choose a few more points just to be safe. Maybe I will actually try a 3. What's it look like when I put a 3 in there? Well, 3 squared is 9. So I'm going to have 2/3 times 9. 3 will go into 9 3 times, and 2 times 3 is 6. So at 3, I am up here at 6. Somewhere right there. So it looks like this part of our graph looks something like this. And it keeps going this direction because we're talking about all the numbers greater than negative 2. So that's what the graph of this piecewise defined function would look like. By the way, we should know that this is a linear function and this is a quadratic function. This one makes a straight line and this one makes a parabola. So remember, this is your straight line and this is a piece of a parabola. It's only a piece because we're limiting the x values that we can put into that function.